Hello, all. Our next topic is causal ordering of messages. This topic is from chapter that is Theoretical Foundation of Distributed System, which is after Lamport logical clock and the vector clock. So herein we are going to see what is this causal ordering of messages. So this causal ordering of messages in distributed system requires this property to be satisfied, which says that for any two messages in the distributed system, if their sent event was uh, uh, following the happen before relationship, and if both the messages are going to the same process, then their receive event should also satisfy the corresponding happen before relationship, which is nothing but, let us say, for any two messages M1 and M2. So if send of message M1 was happened before send of message M2, then the middleware of the distributed system must satisfy or must make sure that its corresponding receive event, that is R1, should also happen before R2 if both the messages are getting delivered to the same destination process, which is nothing but, say for two messages M1, let us say M1 is sent here and M2 is being sent at this point. So herein because S1 and S2 both are in the same process, we can see clearly that S1 is happening before S2. So we can write S1 has happened before S2. Now as I said, S1 is sending message M1 and S2 is sending message M2. Now let us say R1 is the corresponding receive event of M1 and R2 is the corresponding receive event of M2. So herein we can see R1 and R2 is happening in the same process. That means M1 and M2 is getting delivered to the same destination process, as well as R1 is happening before R2. So happen before relationship for the corresponding receive event is also getting satisfied. Now, if this is true, then we say that this particular distributed system satisfies the causal ordering of messages. But suppose if we have a scenario like this, let us say S1 is happening here and S2 is the event of sending message which is occurring at this point in time. Now, herein we can see that S1 has happened before S2. Now, let us say S1 is sending a message M1 and S2 is sending, let me draw it again. So S1 is sending a message M1 and S2 is sending a message M2. And this is the corresponding receive event. So R1 is happening here and R2 is happening here. So from this diagram what we can see is that S1 has happened before S2. Okay, but their corresponding receive event, though both the messages are getting delivered to the same message, same process, but the corresponding receive event what is happening is R2 is happening before R1. So this kind of situation is not acceptable in the distributed system, as the application of the distributed system will not be able to work properly or give the result correctly if the receive event do not satisfy the corresponding happen before relationship as per the sent event, if the two messages are getting delivered to the same destination. Now let us understand this with this for example. In the first example, we have three processes P1, P2 and P3, and three messages are getting communicated, that is M1, M2 and M3. Now happen before relationship, causal ordering of messages, we need to check when same process receives more than one messages, whether their corresponding send event and the receive event are satisfying the requirement of causal ordering of messages or not. Now herein if we see P3 is not receiving any message. Okay, so we need not check for causal ordering of messages here. P2 is receiving one message, that is M2, only one is there, so causal ordering of messages need not be checked. Now if we go to P1, it is receiving two messages, R1 and R3. M1 and M3. So we need to check whether M1 and M3, their sent event, whether there is any happen before relationship between the sent event, then their corresponding receive event should also satisfy the happen before relationship. Now if we see M1 was sent here and being received at this time, and if we see message M3, then message M3 is being sent here and being received at this time. Now let us see whether their sent event is having any happen before relationship or not. Now S1 event is occurring here, then after that S2 event is occurring, then if we just follow the path, then R2 is happening, then S3. Now this we had seen previously, that how to assign the happen before relationship. If we follow that, then we will be able to understand that there is a happen before relationship between S1 and S3. So that means we can say that S1 has happened before S3, looking at this scenario. Now whether their corresponding receive event, that is whether R1 has happened before R3 or not, we need to check. Now if we check P1 here, then we can see clearly that R3 is happening before R1. So it is not about, we need to understand one thing, that it is not about the time, okay, their logical time, or we can say related to the real time. It is not like which sent event was executed before the which another sent event or receive event, whether it is occurring before another receive event. It is not about that. We need to check for the happen before relationship. Now herein if we see in P1, R3 is happening before R1. So that is because S1 happened before S3, the expectation was R1 to happen before R3. But if we see here, R3 is happening before R1. So this message M1 and M3, they are not satisfying the happen before relationship. So what is the requirement in the distributed system is, because the distributed system is built on top of computer network, which is not a reliable system, it may deliver message in the out of order manner. That is, for example, in this case M1 was sent before M3 as per the happen before relationship, but it is getting delivered in the out of order manner. So since computer network may deliver the message out of order, it is the responsibility of distributed system, that is the middleware of the distributed system, to make sure that the process gets the message in order. That is, if their sent event was S1 was happened before S3, then middleware must make sure that R1 is delivered before R3. R1 is executed before R3 in the receiving side. Now let us see the second example. In the second scenario, okay, in the first one, we can see clearly that it is violating the causal ordering of messages, because S1 was happened before S3, but okay, so it is violating causal ordering of messages because S1, we can see clearly that S1 has happened before S3, but R3 is happening before R1, so which is not satisfying the requirement of causal ordering of messages. Now in the second example, If we see P3 is not receiving any message, so we did not check for causal ordering of messages. P1 is receiving only one message, so no need to check. P2 is receiving two messages, that is M2 and M3. Now let us see their corresponding sent event, whether they are having the happen before relationship or they are the concurrent event. Now if we see here, S2 is a event of P3 and S3 is the event of P1. Now checking their sent event, if we see this scenario, then there is no happen before relationship between S2 and S3. That is, they are the concurrent event. Now if there is no happen before relationship between their sent event, then we need not be worrying about the happen before relationship of their corresponding receive event. So herein we can say that it is satisfying the causal ordering of messages. Now in the third example, if we see, again here there are three processes and three receive event, but all three receive event are happening in the different processes. So there is no process having more than one receive event occurring. So we need not be checking for causal ordering of messages. So we say that it is satisfying the CO property. Now let us see the last scenario. In the last scenario also, in P3 there is no receive event. In P2 there is only one receive event, so we did not check for it. Now if we see P1, there are two receive event, that is R3 and R1 for message M3 and M1. Now let us see for message M3 and M1, their corresponding sent event is having any happen before relationship or not. So if we see the corresponding sent event, then okay, for message M1, S1 is the event over here, and for message M3, S3 is the event over here. Now can we give any happen before relationship, or what we can say about S1 and S3 is? So herein we cannot say that S1 has happened before S3 nor S3 has happened before S3. So we will not be able to, we do not have any happen before relationship between S3 and S1, which means they are the concurrent event. So if the corresponding sent event are concurrent event, then we need not worry for the happen before relationship between the receive event. So we say that they are also satisfying the causal ordering of messages property. So this was about the causal ordering of messages. So we need to check if two messages are getting delivered to the same process, then we need to check if there is happen before relationship between their corresponding sent event, then the receive event must also have happen before relationship being satisfied.